Welcome back to our channel, Naval Enthusiasts. Today, we're diving into one of the most revolutionary, awe-inspiring, and technologically advanced warships ever conceived, the incredible Zumwalt-class destroyer. This cutting-edge marvel of engineering has captured imaginations worldwide, representing an unprecedented leap forward in naval warfare, redefining what's possible for the world's leading naval forces. With stealth capabilities straight out of science fiction, weaponry pushing modern technological boundaries, and automation that drastically reduces crew size, the Zumwalt-class destroyer isn't just another ship. It's a bold statement about the future of naval power. Let's start with the basics. Officially designated as a guided missile destroyer, or DDG, the Zumwalt class is named after Admiral Elmo Zumwalt, a visionary chief of naval operations who modernized the U.S. Navy during the Vietnam era. At about 610 feet in length and over 15,000 tons displacement, Zumwalt-class destroyers dwarf traditional destroyers like the Arleigh Burke class, which are around 500 feet and roughly 9,500 tons. Originally envisioned in the 1990s as a fleet of 32 next-generation warships, the program faced significant hurdles, cost overruns, strategic shifts, and technical challenges, ultimately reducing the order to just 3 completed vessels. To truly understand its revolutionary status, we need to examine its cutting-edge design. The Zumwalt-class destroyer employs advanced stealth technologies previously unseen in surface warships. Central to this stealth capability is the unique Tumblehome hull design, a hull that slopes inward as it rises, the opposite of traditional hulls, which slope outward. Historically, Tumblehome hulls appeared on early 20th century battleships, but fell out of favor due to stability concerns. Modern engineering resolved these issues, allowing the Zumwalt's hull design to dramatically reduce radar cross-section. Radar waves striking the hull scatter and diffuse, drastically shrinking the ship's radar signature to approximately that of a small fishing boat, despite its massive size. Further enhancing stealth, Zumwalt incorporates advanced composite materials and radar-absorbent coatings. These composites include carbon fiber reinforced polymers and specialized paints containing iron ball microspheres, which absorb radar waves rather than reflect them. Additionally, the ship's angular superstructure, minimal external features, concealed antennas, and carefully managed heat emission significantly reduce infrared, acoustic, and electromagnetic signatures, making Zumwalt-class destroyers incredibly challenging for enemy sensors to detect and target. Beneath its stealthy exterior lies revolutionary propulsion technology. The Zumwalt-class destroyer uses an integrated power system, or IPS, generating approximately 78 megawatts of power, enough electricity to power a mid-sized city of nearly 80,000 homes. At the heart of this sophisticated system are 2 Rolls-Royce MT-30 gas turbines, chosen specifically for their reliability, power density, and efficiency. The IPS intelligently distributes available power between propulsion, sensors, and weapons, allowing significant energy reserves for advanced future weapon systems, such as railguns or directed energy weapons. Zumwalt-class destroyers employ electric drive motors instead of traditional propulsion systems, drastically improving maneuverability, acceleration, acoustic stealth, and fuel efficiency. Electric propulsion allows smoother speed transitions and quieter operations, especially vital in anti-submarine warfare scenarios. This dramatically increases the vessel's operational range, facilitating long deployments without frequent refueling, crucial for global naval operations. The Zumwalt-class destroyer initially aimed at revolutionizing naval gunfire support with its Advanced Gun System, or AGS. Capable of firing precision-guided, rocket-assisted shells accurately up to 83 nautical miles inland, the AGS promised unprecedented ground attack capabilities. Unfortunately, development challenges and escalating ammunition costs, approaching nearly $1 million per projectile, led to the cancellation of the Specialized Ammunition Program, rendering the AGS significantly less effective than initially planned. Nevertheless, Zumwalt-class destroyers retain formidable missile armament within their 80-cell advanced Mark 57 vertical launch system. This versatile VLS can accommodate a wide range of missiles, including the Tomahawk Block V cruise missiles for precision land attacks, standard missile variants like the SM-6 for anti-air and ballistic missile defense, and anti-submarine missiles like the vertical launch anti-submarine rocket, ASROC. The Mark 57 VLS is designed explicitly for future adaptability, capable of accommodating larger and more powerful missiles without extensive structural modifications. Crucially, the Navy recently announced plans to integrate advanced hypersonic missiles onto the Zumwalt-class destroyers. Hypersonics, capable of speeds greater than Mach 5, offer rapid, long-range strike options against heavily defended targets, fundamentally expanding the strategic value of Zumwalt-class warships. Zumwalt-class destroyers also represent the pinnacle of naval technological integration. Central to this is the Total Ship Computing Environment, or TSCE, a fully integrated, open architecture computer network seamlessly connecting every shipboard system. The TSCE streamlines control of weapons, propulsion, sensors, and communications into one unified and secure interface, significantly improving operational efficiency and reaction times. Cybersecurity features are built in, protecting Zumwalt-class vessels from electronic warfare and cyber threats. In combat situations, TSCE enhances survivability, allowing rapid system reconfigurations and damage control management. Due to extensive automation facilitated by TSCE and advanced machinery control systems, Zumwalt-class destroyers require significantly fewer crew members, approximately 150 sailors per ship compared to over 300 aboard conventional destroyers. Automation covers everything from weapons operation and navigation to engineering systems and damage control, reducing crew fatigue, improving efficiency, and lowering life cycle operational costs. Crew members aboard Zumwalt-class destroyers undergo specialized training, mastering sophisticated integrated systems, robotics, and advanced software control interfaces. Operational feedback from sailors highlights these ships' efficiency, though some have noted the increased reliance on automation demands higher technical proficiency and extensive training. The Zumwalt-class destroyer's operational capabilities extend across numerous critical missions, including anti-submarine warfare, ballistic missile defense, anti-air warfare, precision land attack, and special operations support. Its stealth and advanced sensor suite enable it to operate confidently in contested waters and littoral zones close to adversary coastlines, providing invaluable reconnaissance and intelligence capabilities. Its substantial precision missile capability and potential for hypersonic integration allow it to conduct deep inland strikes against strategic targets, significantly enhancing U.S. naval power projection. Critically, Zumwalt-class destroyers can serve as fleet command platforms, leveraging advanced communication and data integration systems to coordinate complex naval operations across widespread battle groups. Hypothetically, in naval scenarios like those in the South China Sea, the Persian Gulf, or contested coastal waters, Zumwalt-class destroyers could provide decisive advantages through stealthy reconnaissance, precision long-range strike capability, and advanced command and control. Historically, operations in environments demanding stealth, precision, and rapid response, such as Libya in 2011, or recent naval tensions around Taiwan and the South China Sea, could have greatly benefited from Zumwalt-class capabilities. Despite their impressive technologies, Zumwalt-class destroyers have faced substantial challenges and controversy. Cost overruns significantly reduced planned production from 32 to just 3 ships. Originally estimated at approximately $1.5 billion per ship, final costs exceeded $4 billion per vessel. Congressional hearings, Pentagon assessments, and expert analyses pinpointed factors like ambitious technological integration, unforeseen developmental hurdles, and changing strategic priorities as primary drivers of escalating costs. Critics argue the limited number of vessels reduces their strategic utility and that resources might have been allocated more effectively elsewhere. However, proponents counter that Zumwalt-class destroyers serve as technological testbeds, informing future naval construction and doctrine, thus justifying their high costs and limited numbers. Currently, 3 Zumwalt-class destroyers exist: the USS Zumwalt DDG-1000, the class's lead ship, was commissioned in 2016 and continues operational evaluations and testing. USS Michael Mansour DDG-1001, commissioned in 2019, honors Navy SEAL Michael Mansour, who posthumously received the Medal of Honor. Finally, USS Lyndon B. Johnson DDG-1002, launched in 2018, is completing final outfitting and preparations for full service. All 3 ships undergo continuous evaluation and upgrades, refining their capabilities for integration into future naval operations. Looking ahead, the Zumwalt-class destroyers continue adapting to emerging threats and evolving warfare domains. The upcoming integration of hypersonic weaponry exemplifies their flexibility for future combat environments. Moreover, Zumwalt-class technologies significantly influence the Navy's next-generation destroyer program, the DDG-X. DDG-X incorporates lessons learned from Zumwalt in stealth, power management, automation, and modularity, setting standards for decades to come. Internationally, Zumwalt-class advancements prompt allies and rivals alike to reconsider naval design approaches, influencing global naval architecture trends and strategic developments. The Zumwalt-class destroyer embodies a revolutionary leap in naval warfare. Despite undeniable challenges and controversies, these vessels represent unparalleled innovation in stealth, propulsion efficiency, automation, multi-mission capability, and future adaptability. They symbolize America's determination to maintain maritime superiority and reflect the changing nature of warfare at sea. Although limited in number, their technological breakthroughs will influence naval strategy, shipbuilding, and warfare worldwide for decades. Now, we want your perspective. What do you think about the Zumwalt-class destroyer? Are these advanced warships worth their substantial investment? Or should resources have been allocated differently? What innovations should the Navy prioritize next? Let us know in the comments below. If you've enjoyed this deep dive into naval technology, please hit like, subscribe, and click the notification bell. Be sure to check out our other videos covering cutting-edge naval technology and future maritime warfare strategies. Thanks for watching. See you next time.